So when we are working with a function, besides working with graphs, besides working with a list of number, like a set of ordered pairs, like example 1c, or besides working with table of values, it is still possible to put your function in an equation. But we want to make it special. We don't want to call it y equals 2x. We want to make it special so that you are aware of the given function. So we have a new notation for functions. When we are working with a function, we will be using something called a function notation. Starting with f, which is basically the name of your function, we are simply using the initial of the word function in this case. So here we are working with a function that is in terms of x. When you are working with y equals 2x, for example, the x here is the independent variable, and the functions here will help us to calculate the output.
You're saying it's f from x is mx plus b, right?
Not all the time. Well, it doesn't have to be mx plus b. It only applies to linear function. All right. So it could be something else. Your functions can be something else. But let's say if we are working with in general, when you are talking about any function, your functions, you can call your function f, you can call your function g, you can call your function other alphabet, like using other alphabet. And here in this case, if I have a function that is in terms of x, I will use a bracket and put the x in it. We read it as working with a function f that is in terms of x. So once again, for this special notation here, f of x, here we are working with a function f that is in terms of x. That means x is the independent variable. You get to choose whatever value you want for your function. And once you substitute the input, your function will help us to calculate a new value. And that will be your output. So f of x together is considered as one thing. We are not going to split up the f and the x. F of x together means one single notation. This is not the same as f times x. They mean different things. Do not consider this as multiplication. So when it comes to function notation, as I said, you don't have to use f. You can call your function g. You can call your function p. You can call your function a. And your function can help us to calculate anything you want. If you're talking about working with a circle, the radius of the circle will help us to calculate the area. The longer the radius, the bigger the circle. And that means the area depends on its radius. So instead of having an expression like f of x equals something else, we can now use the initial for each of the word here to represent having an area function that is in terms of r, and the equation to calculate the area of a circle can be calculated using this. Another example could be, let's say, What about the distance traveled by your car when you drive on highway number 1 for a certain period of time? Distance depends on time in this case, and we can create a function called v, that is in terms of time traveled by the car. And instead of using f of x, we can now use d of t. We can use this equation to calculate the distance traveled by the car when you have the time given. So these are simply some of the examples for function notation. And all of them can be expressed in terms of x and y instead. Like if we are to turn all these equations back into something we are familiar with, it is basically the same as y equals something of x and possibly add or subtract a number. So it could be y equals 2x plus 3, or in this case it could be y equals 0.12 times x. Or it could be y equals pi times x squared.